Good day, grade 11s. Welcome to this next lesson on Newton's first, second, and third laws. In this lesson, we're going to be looking at specifically action-reaction pairs. And action-reaction pairs are based on Newton's third law. So let's remind ourselves again about what Newton's third law is about. Newton's third law states that when an object A exerts a force on object B simultaneously exerts an oppositely directed force of equal magnitude on object A. Okay, so when object A exerts a force on object B at the same time exerts an oppositely directed force of equal magnitude, so equal but opposite in direction on object A. So let's see what that means. That means that we can get action-reaction pairs. So, for example, an action is that a tire pushes on the road. So action would be that a tire pushes on the road. The reaction would be that the road pushes on the tire. Okay. Let's look at a jet, a rocket. Okay. Yeah, your rocket is pushing gas out. Okay. So the action in this case is the rocket pushes the gas out. But the reaction is that the gas that then actually pushes on the rocket and makes it go forward. So that's how a rocket is actually propelled through space and also through our air. If you see any of the drones and that, the rocket pushes the gas out, and then the gas, therefore, due to Newton's third law, pushes on the rocket. Similarly, if a man pulls on a spring, okay, the reaction is that the spring pulls on the man in that direction, okay? And all these forces are equal and opposite. So, yeah, for example, we've got a little man on the Leaning Tower of Pisa. We can pretend he's Galileo and he's doing his famous experiment where he's going to drop a ball. Then the action would be that the earth pulls on the ball. Now the reaction is that the ball pulls on the earth. But the reason we don't see the movement of that is the fact that the earth is so much bigger than the ball. So do you understand that we always here have got two forces? They are opposite in direction and they're always equal in size. And that is what an action-reaction pair is. Another two very useful examples of action-reaction pairs. If you've ever tried to get out of a boat, it is on the sea or even on the lake, okay, and as you push off of the boat, you know that this boat is actually moving away because your action is that you're pushing on the boat, but then the boat is pushing on you. Okay, so those are action-reaction pairs. And similarly, you've got this poor donkey and he's pulling the cart, which looks a little bit heavy for him. Look at his sad face. So the action is that he is pulling the cart forward, and the reaction is that the cart is pulling him backwards. Okay, so let's talk about what we know about the properties of action-reaction pairs. 1. The same type of force acts on the objects, okay? So it's either going to be a pull or a push or something like that, but there's not two different types of forces. Same type of force. Secondly, the forces have to be the same magnitude. In other words, they have to be the same size, and they're always opposite in direction. And most importantly, the forces act on different objects. It's not two forces acting on one object. The forces are acting on different objects. And that's the most important thing about action-reaction pairs and how to identify them. Right, grade 11s, I hope that this helps you understand action-reaction pairs. Have a great day.